Hey guys, how you doing? Boy, it's a crazy morning, isn't it? But we're doing this class video today because man, we're expecting some big snow tonight. I'm recording this on Saturday night, and we're expecting a bunch of snow tonight, and we want to make sure everybody's safe. But we also want to make sure that we can do a class. There's no reason why we can't do a class just because it's snowing outside, right? So we're gonna do a little recording here, and I don't do this a lot, so just bear with me. And but this says, but since we are doing a video, and this is going to be on YouTube, it's going to be out there for everybody to see. I want to make sure before we get started with the class that I'm going to document the sources of the books that I used when doing this class, so that we're giving credit to the guys who gave me the information. So we're using two books in this class. Of course, we're using the Convicted book that we've been using for this whole quarter. And so Brad Harab's book, Convicted by Associated Press. But this class is also heavily it's going to be taking from another chapter in this book called The New Creationism. And this is by Paul Garner. And so we use this a lot too. And so those are the two sources. And so we'll go ahead and get started then. So I'm going to first share a screen here. I've got a PowerPoint for us. So we'll pull this PowerPoint up. And let's go to the slideshow. There it is. All right, so we got a slideshow going. All right, so this is so you guys, we've been talking about the flood. Last week we talked about the flood, and so this week and next week we are going to look at several things that have caused that are in relationship with the flood. And we're going to look at how the flood may have affected the earth. And so next week, we're going to look at some catastrophic changes that may have happened to the earth. But this week, I want to look at the ice age. So last week, we talked about the flood. And so when you think about the flood, just kind of recap a little bit. When you think about the flood, what's the image that you get after the flood is over and Noah has left the ark? What's the image you get? You see the rainbow, you see the lush mountains. The Bible talks about Noah sacrificing to God. So maybe you see an altar there. Maybe the animals are all gathered around. But you always see this lush green mountain range whenever you see a drawing or something of Noah after the flood. But is this really what the earth would have looked like after it was underwater for a year, after going through such catastrophic, a devastating flood? This really isn't what we would expect to see. This is not what we would expect, because we know that the earth, there was a lot of devastation on the earth, and there is even a good possibility that the flood may have even caused the ice age. And so that's what we're going to be looking at here. Did the flood cause an ice age? Because there's no doubt that at one time there was that the earth was much cooler than it is now, and it was covered in a lot more ice than we see today. And so this is something that creationists and evolutionists, we all agree on. But we do disagree when we start talking about when it occurred and also how many times it may have occurred. And so evolutionists, they're going to start with the belief that the ice age must have occurred millions of years ago. And so that's where they start. And so this belief affects their dating of when the flood or when the ice age started, and it also affects their interpretations of how they look at data. The Encyclopedia Britannica defines the ice age as this. It says, also called a glacial age, any geologic period during which thick sheets cover vast areas of land. Such period of large-scale glaciations may last several million years and drastically reshape surface features of the entire continents. a number of major ice ages have occurred throughout Earth's history. The earliest known took place during the Precambrian time, dating back more than 570 million years ago. So the prevailing thought is there was once an ice age, but that there wasn't just one. There was a many. There's a lot of ice ages and some even estimate there may have been 50 ice ages that have taken place over like over several million years, 500 million years even. So there are some difficulties with this idea though. And so evolutionists, they have a lot of theories about when the ice age may have happened. They have theories about how many times it may have happened. But one thing that they aren't very good at is telling us why an ice age may have happened. They don't know. They say that they don't have enough data to know how it happened. And so, in fact, Louis Ray, he authored an official government publication on the Great Ice Age, and he wrote this in that document. He says, many attempts have been made to account for these climatic fluctuations, but their ultimate cause remains unclear. So they just don't know. They don't know what caused it. So really, the question is were there really many ice ages? Were there a bunch of them, or did it happen hundreds of millions of years ago? So today we're going to look at some of these things. We're going to look at why some of the evolutionist theories are implausible, and we're also going to examine some evidence to see if there might be another explanation for the ice age. All right, so today there's only two ice sheets on the Earth. They're on the North and South poles. We got Greenland and we got Antarctica. That's the only ice sheets that we have. But there's also physical evidence that North America and Europe and other countries that there were glaciers in the past, and that ice sheets were much more prevalent at one time. So one of the most obvious examples of glacier activity is seen in how huge glaciers have carved out the land as they move through the rock and the earth. So we've all seen mountain valleys, how they're when a river carves out a mountain valley, it forms a V shape. So you have it like a V in the middle of the valley, and so this is common. But when you see a glacier eroding a valley, it looks different. It's got a U shape. And so this happens because of how the glacier moves between rock formations, and it carves its way through it as it goes down the slope. The glacier is always going to move towards the lowest point. It's going to let gravity take a hold of it, and so it's going to be carving out the rock as it goes down the slope. And so this is how the glaciers have affected the earth that is around us. And so as it moves, there's going to be other physical evidence, because the glacier, as it moves through the rock, is going to pull up pieces from the hard rock, and it's called plucking. And it pulls those pieces of rock into the glacier, into the ice, and it starts churning around. And some of those rocks are going to get caught, and they'll be on the edge of the glacier. So as that glacier moves, and those rocks are going to scrape against the other rocks that are left behind, and so it's going to leave some scraping. And so it has this kind of a sandpaper effect as the rock goes past those as that glacier goes over the more stable rock, and it scratches big grooves in it. And so we'll see these kinds of things. And as it goes, it picks up the debris, and all of the debris that a glacier causes is called till. And so these glaciers, they're gonna, some of them follow the path of river valleys. And so, every river, the main river, is gonna have other rivers coming off of it that are gonna supply the water to that river. And so if a glacier goes down the main path, what it's going to do is it's going to cause what they call hanging valleys. And then that side river that has supplied the old river, after the glacier melts, is going to cause these waterfalls that fall off of the hanging valley. So it's pretty cool. It's a really neat effect. And so as this glacier moves and it carves out the rock, the till that doesn't get caught up in the glacier is going to be driven in front of it like a bulldozer, or it's going to be pushed off to the side. And so these debris causes rock formations that are called moraine. Moraine, moraine. So these rock formations are left behind after the glacier melts, and this process can carry rocks a great distance. The result is a mixture of various kinds of rocks. Some of them will be of a type that's not normally found in the area that they're laying in. So these are called erratics because these stones don't belong here. We see examples of all of these in the United States. Even there's a distinctive horseshoe-shaped moraine in the Wallowa Mountains in Northeast Oregon. We can see boulders that are made up of the rock formations, but these boulders have come from a source that were 100 or 200 miles up the mountain. So those rocks aren't even found there, but the boulders are there because they were brought down from the large glaciers. So these are just a few examples of how glaciers of the Ice Age have left a permanent mark on our world. So it's important to understand that during the Ice Age, the entire Earth was not covered in ice. The physical evidence shows that about 30% of the world shows signs of having glaciers on it at some point. Compare that to now, where about 10% of our world is covered in ice right now. So the rest of the world would have been colder. It was likely that we had heavier snowfalls during this time, but most of the world was not covered in ice. So don't just dispel that idea from your mind that it wasn't just a bunch of, it wasn't, the world wasn't solid ice, but that the colder regions were a lot larger than they once were. And so, so there is no doubt that at one point there was an ice age, but how long ago was it? And were there more than one? Well, to answer this question, we're first going to have to understand what it takes to make an ice age. How do they form? What causes it? So there's many ingredients that are necessary for an ice age, and all of them have to happen together. And so there's two big ingredients that are important, that are going to be important for us this morning that we'll discuss. So first of all, you have to have summers that are colder than we normally have, and we have to have higher snowfalls than we normally have over a long period of time. And I'll explain that here better here in just a second. Because glaciers are formed when you have heavy snowfalls. They're not able to melt in the summer, and then the next winter, it snows again. It snows really heavy, and it packs that snow down on top of the old snow, and so the snow over time, year after year, starts to compact, and because that snow is so heavy, and it compacts the snow underneath it, and so that snow gets compacted into ice sheets. And so year after year, those continue to grow, and so those blocks of ice get bigger and bigger. But there's another ingredient that's necessary for this to work, because there also has to be a lot of moisture in the air. Okay, because cold weather doesn't cause snow. You have to have moisture in the air for that cold air to cause snow. So it doesn't matter how cold it is, the snow is never going to form because it's too dry. So in fact, we're experiencing that right now in Oklahoma, right? So normally in Oklahoma, we don't get a lot of snow because it's too warm. We get the moisture, but usually we don't have the cold to go with it. So we actually see more ice than we do snow. And so we get, when it does get cold enough for snow, we usually stay between 20, 30 degrees. And that's cold, but it's nothing compared to the northern states and Canada. They get some really cold temperatures, and so they get more snow. So over the last week or so, it's been different though, hasn't it? Oklahoma's been super cold over the last week or two, and so we've had some of those colder temperatures that they see a lot up north. And so, but we haven't had any snow yet. I mean, we've had some flurries, but there's been no real accumulating snow because it's been too dry. But the moisture is coming in tonight. And so recording on Saturday again. So it came in last night for those of you watching on Sunday morning. So now the moisture's coming in, and so the snow's gonna be coming. The snow's on its way because now we have the moisture to go along with the cold. And so but since it's a lot colder than it normally is, that little bit of moisture, it's the same amount of moisture that we usually have with our snow, but it's going to cause a lot more snow because of how wet it is or how cold it is. So you have to have both of those things together. But then also in Oklahoma, our snow doesn't usually last long. It doesn't hang around for a long time. After a day or two, usually our temperatures rebound. We get back up into the 30s, 40, and our snow is usually gone in a day or two. This time our snow is going to last a little bit longer because these cold temperatures are going to be hanging around. So you can see that pattern. See, Canada is much colder and it sees a lot more snow, but it still warms up enough in the summer that the snow melts away. Canada doesn't see the 100-degree temperatures that we see, but they do quite often get into the 70s. That's not uncommon. And so snow can't hang around when it's 70 degrees outside. So in the summertime, it's not cold enough for that snow to hang around. And so it melts off. And so they get a ton of snow the next winter, but it's going to melt off again in most places in Canada. It's going to melt off again over the summer. A study was done by a man named L.D. Williams in 1979. He showed that in order for Canada to form a glacier, it would need to be at least 50 to 55 degrees cooler in the summer. So your summers would have to be 50 degrees colder, and you would have to get twice the snowfall that they normally get. So as much snow as they usually get in the wintertime, they would have to get twice that much in order for a glacier to be able to form. And it would have to do that year after year after year. A freak year wouldn't cause a glacier. So you have to have that continual cycle of snow. So I'm telling you all this because we have to understand how difficult it is for an ice age to happen. It's not going to be something very common. With the scientific idea of uniformitarian conditions, meaning that the present conditions, how we experience our world today, is the same as it was in the past, it would be very unlikely for a single ice age to form, let alone 50. 50 ice ages is just not going to happen. So we've seen how we have to have something in order. If we're going to have an ice age, there has to be something that's going to cause it, something that's going to have a significant impact on our atmosphere and change it, and change the conditions that we understand it today. So it can't be uniform. It has to be something out of the ordinary. Okay, so we do have an event in our history that could have caused a temporary change in our atmosphere. So what is that? Is the flood, right? The flood could have caused some significant change. The flood did cause some significant changes in our atmosphere and our climatic conditions. But could the flood really have caused an ice age? Is that something that it could have done? Well, remember, first of all, how devastating the flood was. Okay, let's look back. We'll review a little bit what we did last week. Remember, in Genesis 7:11, we're told how the waters came onto the earth. It says, in the 600th year of Noah's life, in the second month, on the 17th day of the month, on that day, all the fountains of the great deep burst forth, and the windows of the heavens were opened. So we always think about the flood as the rain's coming down, right? The big storm coming, and it's going to start pouring on him, right? And it does. It rains like cats and dogs for 40 days, but that's not the only thing that happens, right? So this is an underwater vent and from the earth. Okay, so we see these in the bottom of the ocean, but it was much worse back during the flood. It says, the Bible says that the great deep bursts forth, and so the ocean floor opened up, and there was earthquakes, and there was tsunamis. There was catastrophic events, and so these waters from the deep burst forth, and it kept coming. It kept coming for 40 days. This water came up from underneath the ocean floors and from underneath the earth. And it kept hitting, and it kept hitting, and it was very destructive and very devastating to the earth. In Genesis 7:18 through 20, we read this last week also. It says that the waters prevailed and increased greatly on the earth, and the ark floated on the surface of the waters. And the water prevailed so mightily on the earth that all the high mountains under the whole heaven were covered. the waters prevailed above the mountains, covering them 15 cubits deep. So there was a ton of water. There was so much water that it covered even the highest mountaintop, 15 cubits deep. It covered, it went over the top of the mountains. So that much water and that much force caused catastrophic changes to the earth. So we're going to look at some of those in more detail next week. But right now, we need to be concerned with what this did that may have caused an ice age. Okay, so those are the things we're going to focus on right now. So there are two things that would have happened that are important to our discussion this morning. Okay, so first, the friction of all that rock moving around, it would have generated a lot of heat. Okay, so that the earthquakes and all the rock that's moving around as the fountains burst forth from underneath would have caused a lot of friction. A lot of heat was generated. So this heat alone was going to start warming up the waters that was coming out and that was falling down on the earth. Okay, but also this water was really, really hot water because it was coming from underneath. We know that as we get towards the center of the earth that it gets really hot, and so this may have been boiling water coming out. This is really hot water, and we see that in the vents on the ocean floor even today. We see how that water is different. And so it's estimated that the water, that this hot water caused all the flood waters to heat up, and it may have even been as much as 86-degree water. So think about that. That's some warm water to be, if you wanted to take a swim in the flood, man. It was hot water, and that water was uniform all the way around the earth. Compare that 86-degree water to the water today. The oceans today are about 39 degrees. So this 86-degree water, like I said, it would have been uniform all around the earth. In fact, we see the chemical studies of shells that are buried in the ocean floor that they confirmed the ocean was much warmer than it is now. So what would have happened if the entire world was covered in warm water? The first thing that would happen is we're going to have an atmosphere that holds a lot of moisture. You see, warm water evaporates much faster than cold water does. In fact, if there's no other factors, water is going to evaporate 3 times faster at 86 degrees than it does at 50 degrees. And it evaporates 7 times faster at 86 degrees than it does at 32 degrees. So this helps explain why many of the Earth's most arid places show signs of that they were much once wetter. Okay, the Sahara Desert, for example, it shows ancient river channels. That some of these river channels were as large as the Nile River Valley that is today. There are examples all over the earth where of ancient lakes being present in very arid and dry climates. In fact, there are fossils that are found in arid regions of animals like hippos and crocodiles that prefer wetter climates. So these guys like to hang out where it's wet and humid, and their fossils were found in these very dry climates. So we now know that we have one major ingredient for an ice age. We know that the atmosphere was moist because all of this water would have been evaporating into the atmosphere. But that's not where it stops. Okay, there's more to it. See, the waters bursting forth from the deep, it sent the earth into an upheaval. It was thrown all topsy-turvy. It was all messed up. And there's a lot of evidence that volcanic activity was greatly increased at this time. The time just before the ice age and during the ice age, there were eruptions that were not like anything that we've ever seen before. In the US, there's even evidence of more than 68 falls of volcanic ash that coincide with the time frame of the ice age. In New Zealand, there's evidence of a really large eruption from this time period that covered 4 million square miles of Pacific Ocean in ash. So that was a ton of ash, and there was just ash going all over the place. And so we see evidence of this volcanic activity by the presence of lava rock in the fossil record. So this lava rock is found all through the fossil record during the time of the Ice Age. So what is all this ash going to do? It's obvious, isn't it? So all this ash is thrown up into the atmosphere, is thrown around, and so this moist air is going to be filled with volcanic dust. And so all this dust, what is it going to do? It's going to block out the sun, right? And so the sun's going to beat down on the earth, but it can't get through because the skies are black with ash. And so it's going to bounce the UV rays and the warmth of the sun back up into space, and it's going to leave our world very, very cool. The temperatures are going to be dropping, and so now we have the second ingredient for an ice age. Okay, we know that we're going to have a lot cooler temperatures. So with the cooler air, snow is going to be able to form a lot easier. We're going to have much more significant snowfalls, and we're going to have cooler summers, so that snow's not going to melt like we talked about earlier. So we have all the right conditions to be able to have an ice age. And so the snow would have kept the temperatures cooler, and it would have allowed it would allow the cycle to continue longer, because as the ash and the soot from the volcanic eruptions settled, the white of the snow is going to reflect back the radiation also, and so it's going to allow this cycle to continue for some time. So we have all the right conditions for an ice age, and so actually, ironically, evolutionary scientists agree that if there were massive volcanic eruptions all over the earth over a short period of time, they agree that would have caused an ice age. But the thing is they reject that idea because they don't think it actually happened, because it doesn't fit their narrative. It doesn't fit what their worldview says. So they say that all this volcanic activity, we see the evidence. They don't try to deny that. They say, but all this volcanic activity happened incrementally, happened different times over the course of millions of years. So it didn't happen to the point where we had where it could have produced an ice age. So we see that it's very difficult to get the right conditions for an ice age. They don't just happen. But a catastrophic event like the flood could have easily provided the right recipe for an ice age. So in evolutionary theory, the ice age, the way they see it, that the glaciers started up north, and they slowly built their way down over millions and millions of years. But there's a meteorologist named Michael Ord, and he's been studying the post-flood ice age for over 30 years. And so he's kind of devoted his life to this, and he does seminars and teaches about how the flood could have caused an ice age. And so he describes the glaciers forming quite differently than the evolutionists do. So he theorizes that in between the cool temperatures and the warm oceans would have caused powerful storms along the eastern coastlines of Asia and North America. And these storms would have created what he calls snow blitz. And so he says that all this snow would have resulted in ice sheet buildup very rapidly and simultaneously across large areas of land. And so Ord claims that these conditions would have been right, that there would have not needed to be 10,000 years to develop glaciers, as the evolutionists claim. He estimates that the peak glaciation of the ice age would have happened between 170 to 1700 years or so. He says his best guess is about 500 years for the ice age to form and to die away. Well, no, to form. We'll talk about how it retreating in a minute. So he says it takes about 500 years for it to reach its peak. But what is really interesting is that he estimates how long it would have taken for this ice to melt away. So his calculations show that the ice would have melted away at a rate of about 30 feet per year. The reason why it's interesting is because this just so happens to be very comparable to the rates that we see glaciers melting today in Alaska and Iceland and Norway. We see that's about the rate at which they're melting at this very moment. So at this rate, all the ice in the world would have been able to melt away in the ice age in between 100 and 200 years, so depending on the total estimates of ice formations. So add that all up together, and so given a couple of 100 years for thawing, the ice age would have only lasted 700 years. So this goes against the conventional wisdom of the evolutionists. They don't believe this. So they claim that ice core samples from Greenland glaciers show that the ice there in Greenland is 10,000 years old. But the thing is, those estimations are flawed from the very beginning. You see, these estimates are based on the assumption that Greenland and Antarctica are very old. So they believe that these ice sheets have been formed over millions and millions of years. And so when they dig out their core samples and they count their layers, they claim each of these layers are annual layers. And so that's how they start to get their age of the glacier. So they begin with assumptions. So when they try to figure out how old it is, they start off with conclusions that are already flawed, because they assume age in their estimations. And so if the ice sheets are actually in fact younger than what they assume, then it would that means there would have been less time for compression, and if that's the case, then we would read those layers completely differently. So what the evolutionists call annual layers may just be individual storm layers. So it could have formed a lot quicker than what the evolutionists claim. So this leaves us one more question. It leaves us about how many ice ages there were. So were there really 50 different ice ages? So the multiple idea of ice ages really is an assumption. Because most areas that show evidence of glaciers actually show only evidence from one ice age. And so the assumption, their assumption comes from the fact that along the edges of the ice sheets where there appeared to be some layering. And so they say that one ice age came and then another one came and put more layers on top of it. And so this could be interpreted, though, as multiple or to them, this is interpreted as multiple ice ages, but it really can be explained in other ways too. This could come from a single ice age, and the edges are just surges, and where the glacier has surged and retreated and surged and retreated. So there's some fluctuation, but it's all from one ice age. It happened over a very short period of time. So if we take a step back and we look at an ice age, from a distance, it becomes clear that one ice age is much more likely than 50 ice ages. Let's look at some reasons why. We've already seen one way, because we spent a lot of time already showing how difficult it is for an ice age to form. It's more likely that an ice age would not form than to form. So it's much less likely that many would form when it's so difficult for just one to form. It would take something extraordinary for an ice age to develop at all. Okay, so next we see that there's very little evidence, quote unquote evidence, for ice ages that are attributed to previous ice ages. Does that make sense? So the evolutionists say that the last great ice age corresponds, when they describe that, it actually corresponds with the one ice age that the creationists acknowledge. And so they call this the last great ice age, but we just call it the ice age. And so, because almost all evidence for any ice age is attributed to what they call the last ice age. So they say this is because they say that all the evidence is in the last ice age, because each successive ice age erases all the evidence from the previous ice ages. So they're saying that there was an ice age, but all the evidence got erased when this next ice age came and took it over. And so it's very convenient for them that way. But all that evidence is sitting in that last ice age. We also see that that if there had been 50 different ice ages, we would expect the till, all that debris, we would expect that to be massive. The reason is, okay, if we look at the examples in Canada and we see we see glacial till between 70 and 30 feet. So that all that rock that glacier picked up as it was moving along, what was left behind is about 70 to 30 or 7 to 30 feet of debris. And so if we compare this to the till that's left by modern glaciers, we see that this is very consistent for one single event. For example, the till that we see in Glacier Bay, Alaska, is between 3 and 15 feet. So but the thing is, this till has built up over the last 200 years. So this doesn't necessarily mean we need a million years of buildup. If all this has happened and 50 ice ages had happened, we would have a bunch of debris from that. We just don't see it. Okay, so another one. See, nearly all of large animal extinctions that were the result of an ice age, almost every single one of them occurred in the last ice age. So there's very few extinctions that evolutionists try to blame on earlier ice ages. So how is it that all these animals were able to withstand 50 other ice ages, but the last one seemed to wipe them out? It just doesn't make any sense. See, everyone, this is just a few of the questions that the evolutionists just can't answer. In fact, there's plenty of evidence that the flood may just have caused the ice age. And it's not unreasonable to think that, and we aren't crazy if we believe that that's possible. And so if you have any questions over this, please let me know, because there's a ton of more information. I tell you this every week. There's a lot of information that I've had to just skip over, and I'd be happy to share it with you. And we can answer some of your questions. If you think, Phil, you're a nut, there's no way this is true, come talk to me. We'll work through it. So, guys, it was great being able to talk to you today. I wish I could interact with you, but here's a lesson, and I hope you enjoyed it. And I hope you have a nice, safe, warm Sunday. And we'll see you after all this stuff melts away.